Okay, for 139, they want to know how many solutions they have, so we can use the discriminant. So for A, right, A is 6, B is 7, C is negative 20, and we want B squared minus 4 times A times C. So that's 7 squared minus 4 times 6 times negative 20. That's 49, right, plus, and we don't even need to figure out this number in reality, right? I mean, it's 120 times 4 is 480. But clearly that's a positive number, so this has two solutions, right? Since it didn't ask to find the discriminant, we really don't have to, but we can. Here it's 529 is the discriminant, and it has two solutions. Okay, for B, let me make space. B, we have A is 1, B is negative 8, C is 16. We want B squared minus 4AC, so that's negative 8 squared minus 4 times 1 times 16. That's 64 minus 64 is 0, so that means there is one solution, right? If the discriminant is 0, there's one solution. And C, let's make space. We have A is 2, B is 1, C is 3. Again, and I'm getting A, B, and C by, the form y equals ax squared plus bx plus c, right? Okay, so b squared minus 4ac is the discriminant. So b is 1 squared minus 4 times 2 times 3. So 1 minus 24 is negative 23. So if the discriminant is negative, there's no solution, right? And the last one, D, we have y equals 2x plus 1 squared. So let's just think about this. Since it didn't say using the discriminant, this is, if I were going to find the zeros, it would be 0 equals 2x plus 1 squared, 2x plus 1 times 2x plus 1. So the zero product property says that this is going to be 0 or this is going to be 0. But these are identical, so there's really only one solution, and this is it. There's one solution, right? And if we wanted to carry it further, we could. If it said find the solution, which I don't want you to do, but we would say, 2x plus 1 is 0. 2x is negative 1, x equals negative 1/2, and that would be the only one solution.